Hello, OpenJS world. My name is Owen Buckley, and I'm excited to talk to you today about web components at the edge. I'm really excited about this talk. I think it's going to be neat to showcase how a traditionally thought of feature like web components, which are browser-based, working in server and server rendered environments, and specifically today's talk, running them in serverless functions and at the edge. So a little bit about myself. I consider myself an open source and web enthusiast, currently working as a UI architect at Lending Club. I've listed a few of my links if you want to get in touch, and if you happen to be a live music fan, Tuesday's Tunes is a show that I put together with a friend of mine. I do the live streaming, production, recording, and all those good things. And my friend does the performance. So feel free to check that out if you want a little something different. But yeah, let's get into the talk today. So I wanted to run through the elements of the talk, specifically edge and serverless functions and what they're about, and go through a little bit about web components and server-side rendering with them. I think what's neat about this talk is taking a browser API and getting it to work in a server environment, and with serverless and edge, a little bit more of a constrained environment, but doable nonetheless. I'll give a demo of these all working together with the code available with the slides that I'm sure will be provided through the conference. It's also in my GitHub if you want to find it that way. And then we'll wrap up, give some considerations and thoughts to consider based on what I was able to share, and some ways that you can stay connected with the web components community. So yeah, let's jump right in. So what is the edge? Well, the edge is a kind of a next level on top of serverless functions. I'm going to kind of classify and demo serverless and edge together. They have a lot in common, with the nuances of edge being a little more limited in its surface area, but fundamentally, the underlying concepts are quite similar. But to start the conversation, I figured I'd just start off with CDNs and their role in front-end development. I think there's some analogies here with the rise of serverless and edge, and I think a lot of that ties to just how simple it is to use a content delivery network for static assets, how easy it is to, from a single origin, distribute those all across the world, make it a lot easier and performant for your users and as a developer. And really, when you use a CDN, you just have to upload your file somewhere, and your CloudFront or Cloudflare pages is really going to take care of the rest of it for you. There's that level of simplicity and approachability that I and a lot of others see with serverless and edge computing. And you could say that serverless and edge are the dynamic to the static of CDN. And I think together they make an incredible combination for web development. So these are some of the popular CDN providers. I'm sure you've heard of them if you haven't used them. And a lot of them also provide similar capabilities for serverless and edge functions. So that's really handy. And so if you've never seen a serverless function, it should in practice look fairly familiar if you've been writing JavaScript. It's really just a function that follows a couple conventions, like maybe it has a name depending on the platform provider. But for the most part, it gives you a pretty robust access to a lot of the features that you've been used to while working on the web, like fetch or depending on the runtime, some NodeJS APIs or whatever your language of choice is. But really, just like with the CDN, you're writing your front-end JavaScript, you're not really thinking about the distribution side. You're not really writing it with servers in mind. And same with a serverless function. Here, I can just fetch some data and then iterate on it, return it as HTML. And there's nothing about the infrastructure or the platform I'm running on really in this function. I'm just writing the logic that I want. And just like a CDN, you just upload the files to a location and the provider takes care of the rest. Similar for these serverless and edge functions. Typically, your provider will maybe have a designated directory or somewhere to put it in, and it just picks it up from there and off it goes. But I think very simple and straightforward to integrate into a workflow. And I think the CDN systems have kind of provide a lot of guiding light and principles. And it's great to see the dynamic side of web development really embrace some of the simplicity and straightforwardness like we've been used to with CDNs. So some of the benefits, I've mentioned a few, and they share a lot with CDNs. What's really nice for serverless and edge is, unlike an actual server, they're on demand and cost effective because you're only paying for the function calls that happen. There's not a server just running 24/7 waiting for someone to hit it. And so hopefully your costs are a lot better as a result. And like I said, they share a lot of similar traits with CDNs in terms of being fast and cacheable, but now we get the added bonus of it being dynamic because it's not just static assets across the world, but with edge functions, you get compute across the world. So pretty cool. But edge functions do, sometimes there are trade-offs, and so edge functions are no different. So while they do get you closer to the user, they do tend to be a little more limited in their API surface. So that's definitely something to keep in mind. The goal is to try and keep things performant and do quick operations. If something you need incurs a lot of overhead, serverless function or might be a better choice. So just something to keep in mind as we go through this. So just to touch upon the points I made. So a CDN is great for static content. Serverless is great for on-demand compute. And edge is great for geographic compute. And in this demo, we're going to use them all together, and you can too. So about web components and server-side rendering. Let me go through that a little bit. So first, what are web components? Well, they're an umbrella of a few different features that are available in browsers, HTML templates, custom elements, and shadow DOM. And together they combine to make kind of the web components capability, which effectively, just like you might see in the browser with things like date pickers, allows you to define your own HTML tags and attach styles and behavior to them. And so this is an example of what one might look like. So here we're creating a template which allows us to interact and manipulate inert DOM, which is not rendered by a browser, but we can use it to create HTML that will be used in the DOM, specifically shadow DOM, as I scroll down to show you. Web components, custom elements are just classes, and so they inherit from and extend in base HTML class. So that's what we're doing here with our footer. We have our connected callback. So like a lot of front-end frameworks, React before hooks, Angular, and the like, custom elements have lifecycle methods for like when they're attached to the DOM, and constructors that comes with classes, of course. Various ways to observe changes in the state and the attributes. So, and in this case, we're going to take the template that we created by first creating a shadow root with attached shadow, and then appending the contents of that template into it. And that's how we'll be able to provide our shadow DOM boundary to the browser. And shadow DOM is effectively a way to hide and encapsulate the implementation details of this template, so the styles and the markup, from the rest of the DOM. And so provides a really nice mechanism for components and widgets and things like that. And then lastly, so the browser can be aware of this definition, we provide it the tag name we want to use, and then provide a reference to the class and call custom elements.define. So that's the anatomy of a web component. Now, in a browser, this is all well and good, but we're trying to run this on the server, specifically in our serverless and edge functions. And so if we were to run this footer.js through Node, we're definitely not going to have a good time. In fact, this is what you'll see. Document is not defined, which makes sense. NodeJS is not a browser runtime. It does share some APIs like a fetch and promises, but it does not have any concept of window and things alike. So that's a bit of a bummer, because if we look to, say, other frameworks, like say React, they provide a very handy render to string function that you can call, and you can pass in your React component and out comes HTML. So that's pretty nice. And so I put together this presentation because I want to show you that you can achieve this outcome. And I'm not using Puppeteer for it, but we can render web components in a server environment, even at the edge and on serverless functions, and really get, I think, pretty far just with what we have now. So what makes this possible is the fact that all these items that we used, all these features we used to create a web component, they're all browser standards. You can go to MDN and look these all up, and you can learn exactly how to make them work. And with that, you can shim the runtime environment to provide the basic mechanisms to facilitate the behavior, like the life cycles and how a document fragment works. I think that's pretty great. MDN is awesome. I learned a lot through this, and thankfully it's a spec. So it's something that the entire web can agree on. So what I'm rendering on the server, I know will have compatibility in the browser. So that's always good. But if we look to the React example, there isn't an actual render to string method anywhere on the web, right? How do we get from our custom element in Shadow DOM to actual HTML? Well, standards come through once again. And so what we have access to, and what will in some browsers now and more in the future, is the idea of declarative Shadow DOM. So now we can express the inner contents of that shadow root, the styles, the HTML, the markup, even mix it, blend it with our own content outside that shadow root, inside our custom element tag. and we can ship that as HTML. We can effectively achieve the equivalent of render to string for web components. And we have that specification that browsers can use to effectively pick up that HTML without any JavaScript and still achieve some of those effects. So that's pretty awesome. And so a full example of a declarative shadow root could look like this, where we have our template and shadow root open. This is the new key feature. We can set our styles to manipulate slotted content, provide some default content if it's not provided, but in this case, since we have an element associated with each slot, this will be projected into our shadow root. So pretty cool. This is what we like to see. HTML, more of it. It's great for the web. It's even better for web components. So to recap, we can shib Node.js. We can pre-bake out that HTML using web standards and even no client-side JavaScript, depending on the use case. And we can apply techniques like progressive enhancement and hydration because we can leverage that initial HTML as a hint to our client-side code to say avoid operations that require rendering that HTML. So that's pretty nice. Hydration is coming to web components and it's pretty sweet. And so the only question I have is, what are we waiting for? So let's get to the demo. So I've got two demos, one running in a couple examples running in serverless functions and edge functions. So for the serverless example, I'll be using Architect, which is a framework for working with AWS, and my own tool that I've been working on called Web Components Compiler. This is what effectively gives us the that render to string functionality. It'll be able to run your custom elements in a Node.js environment and handle things like the life cycles and rendering out to declarative shadow DOM and things like that. So let's check it out. Okay. So the first example, I just wanted to start very simple, is just like what we saw in the slides. Let me pull up the network tab here and I can show you. So we have some text, some styles on the page, no JavaScript. And so if I look at the response, we can see that we've got some declarative shadow DOM here. We've got our template with the shadow root open. We've got our styles, which we see here in the header and throughout the page. Here's an example. We can even see our light content projecting through, so demo 1. And then our footer as well. So that's pretty neat. Let me just show you a quick example of what that code looks like. So like I said, it's all hard-coded, but here's what our function looks like. So we're just sending it back as HTML. And yeah, just hand writing, hand crafting it all out, just as you saw in the network tab. Okay, so that's a basic example. That's fun to kind of see it in its plainest form. But let's do something a little more complicated. So here I'm going to have an example with some data fetching, and in the function I'm getting an array of these artists, and I'm going to render the name, and you see it's in green. I got the photos, and I can scroll through the list, and we got the horizontal rule, and then here at the end, a count of them all. So if I go back to the network tab, focus on the JavaScript. Again, no JavaScript. but we are getting all the styles. We are getting all the HTML. So that's pretty neat. If I look at the source here, we're just going to see a whole lot of these WC card elements. Here, let me make that a little bit bigger. All right, so WC card, all the styles. Cool. Even the slotted content. So yeah, so let me show you a little bit about what that code looks like. Okay, so here we're getting the list of artists, and now I'm using one of the methods from WC compiler where I can pass it a bunch of HTML and any custom elements at the top level. I'm only using a card component right now, so I just pass it the path to that, and effectively that's going to, from this HTML, it rendered out all these cards that you see here, and all of it with declarative shadow DOM. I didn't write any declarative shadow DOM in my function. That's what my card is doing. Yet I got declarative shadow DOM in the output. And we can see here, if I scroll down, now we're just rendering HTML right into the response. You can ignore this replace. That's just an enhancement I need to make to WC compiler. But yep, all rendered server side, no handcrafted declarative shadow DOM. I just expressed my custom element with the light content that I wanted, and WC compiler took care of the rest. Okay, a couple more before we wrap up here. Okay, so this I think is going to be a really fun demo. So here I've added a couple more elements to the page, and you'll notice that in this case there is some JavaScript loaded for the header. It's to enable this button click here. So if I click this button, we'll see that we get an alert, just as I wrote in the code. And so here's an example of how we can take advantage of declarative shadow DOM. So when the component connects, if it doesn't have a shadow root, which will happen on the server side, it'll render that. So that's what you're seeing in the serverless function. That's already happened. This doesn't need to happen again. And in the constructor, because the browser knows what a shadow root is and effectively hydrate from declarative shadow DOM, we don't have to do any of this extra rendering shadow root work on the client. We can just, like a React hydration, for example, we just pick up from that initial HTML. And in this case, I'm just adding a click event to that button, which we just saw. I'll do it again. Yep, there we go. Okay, so next thing I wanted to show off real quick here is I wanted to show off an example of progressive hydration. So I'm going to scroll down, and you're going to see some text in the bottom left corner. That's going to be coming from this slider component here. Let me go to here, scroll down. Yep. So we're going to see this text. It's in the form of this slider component. So I'm going to scroll down. Let me filter for just JavaScript. So still only the header component. We're going to scroll, scroll, scroll. Oh, hey, so we see our text now, but now we get an alert. Hey, we intersected WC slider, time to hydrate. So that's interesting. So what I'm doing right now is I wired up an intersection observer and told it to observe the WC slider tag. And when that tag comes into view, it's going to load WC slider.js. And then something fun is going to happen. But I do want to point out that we are getting the benefit of declarative shadow DOM on initial render, because you can see there's no slider.js yet, but we've got our green styles. So here's the hydration progressively happening. I'm going to click OK, and you're going to see two things happen. First, we loaded slider.mjs, and we then saw it animate across the page. And that's because using our declarative shadow DOM, we can just pull from the shadow root and add a class. The color is actually coming from an attribute that I set on the HTML initially. And then I just attach this hydrated class to it, and that's what gives it the animation. So pretty neat. This was really fun to put together, and pretty exciting to see some of the potential here. So these were all examples of serverless functions. So to close out the demo, let me show you an example of an edge function. So I have a list of demos on the edge function demo page. The first two are effectively what you saw before, just done in edge functions. And so what I want to show to close this out is one of the advantages of edge functions specifically, because they are kind of geo-distributed. They come with the ability to get, say, geolocation data. And so in this example, I'm going to be using Netlify edge functions with WCC. So let me click on that. Cool. So let me pull up the network tab here just to show you. So if I refresh the page, no JavaScript, but we are pulling country and the code, the country name and the code from the geolocation data available in the edge function that I ran. And so I just rendered out, same kind of header as before, and then just rendered out the content here. So let me show you an edge function. So let me go to demo 3. So not too different from the serverless example. It's still just a function here. As I mentioned, edge functions are a little limited, so I'm just using WC compiler's DOM shim for the time being, since I don't have access to FS, but I'll be fixing that very soon. So WC compiler will be totally able to run in edge context. But here we can see that in the context, I can get the code and the name. And since components are just custom elements are just classes, I can just instantiate them myself. I can initialize them myself. And then I can just extract the HTML myself. And same thing using slots and projecting content. And then, I can just render out some data as well. So yeah, those are some of the demos that I have. These are all linked to from the slides, which I'll go back to. So I already did that, and I just did this example with Netlify edge function. So yeah, so I think just to close out here, leave with a couple considerations for you to think of. So declarative shadow DOM support in browsers is still new-ish. It's available in Chrome and Edge, and there's a tiny client-side polyfill to enable the functionality to make that work in other browsers like Safari. Just keep in mind as you get closer to the edge, the smaller the runtime surface area, like I referenced in the demo. Edge functions don't have access. A node edge function isn't going to have access to FS. In fact, I think edge functions are kind of really considered their own runtime. It's a much smaller version of JavaScript, and it typically relies on web APIs, specifically like fetch, request, response. And so you might not get a node edge function specifically, but you can certainly code around it. Lots of teams are doing this through like adapter patterns and things like that. So definitely possible. And so you saw a little bit of the work is manual at this time. It's mostly just because I'm, kind of new to gluing this stuff together, but tools definitely exist besides mine, which I'll show off in a second. So for the community section, I did just want to leave with some links and some opportunities to stay connected and to get engaged. As I mentioned, there's plenty of solutions, good solutions out there already, trying to pave this path. There's Lit, which is a front-end library for authoring web components. They have an SSR solution. There's Stencil and UHTML that have support for server rendering web components. And then what I was showing off, which is my new project, which is WCC. It's still new, it's experimental. It's right now just tailored for native HTML element, but I think it did pretty good for the sake of this demo, and I'm really looking forward to putting some more work into it and really making it nice to use and hopefully trying to support a decent amount of the web components API surface without treading into headless browser territory. And so communities that I think are worth getting involved with. Lit has a Slack channel that's very active and engaged and brings a lot of people from around the community who are getting involved in web components. There's a group that I'm involved with, the Web Components Community Group, that's part of the W3C. We're actively trying to push for good documentation and guides on using web components and really exciting community protocols where we're discussing interop for things like HMR and SSR, hydration. So definitely check that out if you're looking to kind of learn more about spec work and web components specifically. Project Evergreen is the GitHub org where you'll find WCC and some of my other web component related projects like Greenwood, which I like to call your workbench for the web, kind of a hybrid static site, serverless site builder tool. And my own personal Slack, the Greenhouse, where you can come and chat about some of those projects or anything at all, web and JavaScript and all that good stuff. So the community is out there. We're looking forward to seeing you and hearing from you and open to your feedback and contributions and participation. So on that note, just want to thank you, OpenJS World, for having me speak this year. Really appreciate the opportunity, and I hope everybody has a great rest of the conference. Thank you. Bye.